Write each of the following sets in roster form and write its cardinal number. So you just have to write in roster form. So you need to know first of all what is this over here. You need to read this. So set A is X such that X it belongs to W. Earlier on I had told you W stands for whole numbers, and whole numbers begin from 0. Okay. So how many whole numbers are we to write? X is less than 6. So you write whole numbers which are less than 6. So you need to learn how to read the set builder form sets. If you are able to read and understand the properties, then you'll be able to list it in the roster form. So here whole numbers less than 6 means 0, 1, 2, 3, 4, 5. So set A will comprise of those elements. And then you are also to write its cardinal number. Now cardinal number means how many elements are there in this set. So there is 0 to 5, that is 6 elements. So the cardinal number of A will be 6. Next, X set B equals X such that X belongs to N. N is a natural number and it is a multiple of 4 and it is less than 30. So there are three things that we know, that we want natural numbers which are multiples of 4 and less than 30. So which are the multiples of 4? 4, 8, 12, 16, 20, 24, 28. After 28 is 32, but that exceeds 30. Therefore, we stop at 28. Next, and cardinal number also, of course. Then set C, N means it's a natural number. It is a perfect square and less than 30. So all the perfect squares that are less than 30. Set D, natural number, composite number, X is more than 10 and less than 18. So all the composite numbers which are more than 10 and less than 18. So remove the prime numbers and the remaining numbers will be composite numbers. We know that between 10 and 20 the prime numbers are 11, 13, 17, 19. These are the prime numbers, but we are not talking about prime numbers over here. We are talking about composite numbers. So excluding these prime numbers, whichever numbers are greater than 10 and less than 18 are to be listed in set D. Next, set E. X is an odd prime number. So we want odd numbers, prime numbers, which are odd numbers, and they have to be less than 18. So we write all the prime numbers which are less than 18 except 2, because 2 is the only even prime number. All other prime numbers are odd numbers. Next, X belongs to N, means X is a natural number and X is more than 5 and less than 6. Now there is natural numbers means counting numbers. So more than 5, which next number will come? 6 will come. So here they are telling we want a natural number which is more than 5 and less than 6. There is no such natural number. Soon after 5 we have 6. So there is no number which is more than 5 and less than 6. We have decimal numbers in between. We can have fractions in between, but we cannot have a natural number in between 5 and 6. Therefore, this F, set F will be having no elements and therefore it is an empty set, a null set, a void set. So you can simply write F equals, and you can write the symbol for phi, which is that symbol of phi, the circle with one line across it. That is the symbol for phi. Next, X such that X is a letter in the word Allahabad. So all the distinct letters of this word you are to write. Distinct means different. If the letters are repeating, you don't write them. And not to forget, after you list the elements, everywhere you are to write the cardinal number. That's how you'll do question number 1. Let A equal X such that X is a letter in the word increase. Okay, so in this set A, we have to write the letters of the word increase. So again, it will be distinct letters only, meaning the separate ones. So which are the elements of set A? I, comma N, comma C, comma R, comma E, comma A, comma S. Now no writing this E because we have already written it here. So those will be the elements of this set. Now set B equals X such that X is a vowel in the word increase. So in this set we want only vowels which are there in this word. So we know that vowels are A, E, I, O, U. So of these, which are there in this? I is there, E is there, and A. So I, comma E, comma A. O and U is not there. So these three only you will write for this set. And C, X such that X is a consonant in the word increase. Now consonant means letters that are not vowels. So vowels को छोड़ के जो भी letters है, those are consonants. So just now we wrote vowels over here, I, E, A. So I, E, A को छोड़ के all the other letters will be elements of set C. So N, C, R, S, these four. Okay. Now what is asked? So first we have to list the elements of these sets. Write A, B, C in roster form. So we just did that. Then question number 2 is you have to find the cardinal number of A, cardinal number of B, and cardinal number of C. So you need to just count the number of elements in these sets and that will be the answer to your second question. Next, question 3. Which of the following sets are equal? Now, what is the meaning of equal sets? That these elements are same. Okay. Now, the order in this is not necessary, not important. And even if there is repetition of elements, it is meaningless. So, remember what are equal sets. If you want a quick revision, we can look here. It is on page number 130. Yeah, equal sets. Two sets are equal if every element of A is in B. Means whichever elements the set A is having, it will be there in B. And every element of B is there in A. So all the elements of B are there in A. Then we can tell A is equal to B. Okay. Now I just told you the order in which elements are listed is immaterial. So whether one of the sets is 1, 2, 3 or 2, 3, 1 or 3, 1, 2 or 3, 2, 1, all that doesn't matter. Next, even if there is a repetition of elements, it doesn't matter, like it is meaningless. Like if it is 1, 1, 2, 3, 3, it means this set consists of 1, 2, 3, only 3 elements. Okay, so this is equal to 1, 2, 3. And if it is 1, 2, 2, 3, this also means 1, 2, 3. So repetition is meaningless. Okay, then this also we had done the other day. So that is the meaning of empty set, equal sets. So here we have to see if they are equal or not. So if we have to see that, first we need to know which are the elements in these sets. So we first write down these sets in roster form. Only if they are in roster form, then it becomes easy for us to identify the elements and tell whether they are the same in both. So what is this? X such that X belongs to N, means X is a natural number, means it is a counting number 1, 2, 3, 4, 5. Okay, but X is more than 1 and less than 3. So there is only one natural number more than 1 less than 3, and that is 2. So in this set we have the element 2, only one element is there. So it will become a singleton set also. A singleton set is a set which consists of only one element. Now we look at what elements are there in set B. Set B equals X such that X is prime, X is even. So we want a prime number which is even, and we know that there is only one number which is an even prime number, and that is 2. So set B also consists of the element 2. Here it was 2, here 2 it is 2. Therefore, they are equal sets. So similarly, we have to do for the others. So you need to understand what is given here again. X such that X belongs to W. W is a whole number, means X is a whole number, and X is less than 8, means 0, 1, 2, 3, 4, 5, 6, 7. Okay, all of these placing commas in between. And then X such that X belongs to N, means these are natural numbers, and X is less than 9. So we have to write natural numbers, that is 1, 2, 3, 4, 5, 6, 7, 8. So in set C we have 0 to 7. Set D we have 1 to 8. So are they equal? No, they are not. There are certain elements. There is one element which is here and not here. There is one element which is here and not here. So they are not equal. There is a 0 here. There is no 0 here. Here there is an 8. There is no 8. Okay. So when you list these elements, you will understand it better. Next, X such that X belongs to N. Again, it is a natural number. It is odd and it is less than 6. All the natural numbers which are odd numbers and less than 6. So which are those? 1, 3, 5. Okay. And next, X such that X is a natural number. X is a factor of 15 and X is less than 15. So you have to find out the factors of 15. First of all, the factors of 15 are 1 and 15, 3 and 5. 3 5s are 15, 1 15s are 15. So there are 4 factors of 15, but we are not interested in all. We want only factors of 15 which are less than 15. So 1, 3, 5. And there also it was 1, 3, 5. Therefore, both of these sets are equal. Next, prime factors of 12. Which are the prime numbers that can divide 12? Only 2 and 3 are prime numbers which can divide 12. And here X is a prime, X is prime and X is less than 4. So we want prime numbers which are less than 4. So 2, 3. So now both are same. So it will be equal set. Next, this is the symbol for phi. Phi means empty set. Means a set in which there is no element. Khali, ekdam khali. And this stands for a set in which there is one element 0. इसके अंदर this set के अंदर एक element है 0. Okay. So these both are not equal because in this set there is nothing. Here there is one element. Next we go to which of the following are empty sets. Okay, now listen to this carefully because this is slightly different from what is given earlier. X such that X belongs to N means X is a natural number, and when you add 3 to this X to this number, it will become 3. Okay, so which number you will add 3, will you get 3? Set B, X such that X is a whole number, and when you add that whole number to 5, you will get 5. Okay, so what I just explained here, that will apply over here. Now whole numbers, we know they start with 0. So if you add 0 plus 5, you can get a 5. So in this set, there is one element. So it is not an empty set. Now if you take the next whole number, which is 1, then 1 plus 5 will not give you 5. So 1 is not an element of this set. In this set, there will be only one element which is 0. So 0 is the only whole number which when added to 5 can give you 5. Next, x such that x belongs to natural numbers. X is even, x is divisible by 3. Means we want natural numbers which are even numbers and which are divisible by 3. So any number if it is divisible by 3, it will also be a multiple of 3. जो 3 से divide हो सकता है, मतलब वो multiple of 3 है, isn't it? So all the numbers that can be divided by 3 are 3, 6, 9, 12, 18. But we are not interested in all the numbers that are divisible by 3. Here they are telling us that we want only even numbers. So yeah, one hint is given. So of all those which I said, you have to just pick even numbers. So first number which is divisible by 3 is 3. But it is odd, so you don't write it. Next is 6, it is even, so you write. Next is 9, it is odd, so you don't write. Next is 12, so you write it. Now when you keep listing this, you will observe that this set is an infinite set. It continues forever and ever. Okay, so it is infinite and definitely not an empty set. Next, x such that x is a prime number, x is less than 2. Now we know that prime numbers begin with 2. So there is no such element which is a prime number and less than 2. Therefore, set D is an empty set. Next, x such that x is an element of natural numbers and it is less than 1. Now we know natural numbers begin with 1. So we don't have any natural number which is less than 1. Therefore, again this set is empty. Next, x such that x belongs to a natural number and 2 times x will give you 1. So we want a natural number, and when we multiply that natural number by 2, 2x means 2 multiplied by x. We want 1. Now natural numbers begin with 1, isn't it? So if we are taking x as 1, so 2 multiplied by x means 2 multiplied by 1. You will get 2. You won't get 1. So there is no such number which when multiplied by 2 will give you 1. If you divide 2 by 2, you can get 1. But if you multiply, you will not get. So again, this is an empty set. And the last one, G, this set consists of 0. So already there is one element in this. If this element doesn't have value, we are not bothered about the value of the element. Empty set means elements are there or not there. Okay, so here there is an element, so it is not empty. Next, classify the following into finite and infinite sets. So you have to tell whether it is a finite set or an infinite set. Again, you need to understand how to read sets given in set builder method or rule method. Again, x is a natural number and less than 100. So there are limited natural numbers less than 100. We know all the numbers from 1 to 99 will be a part of this set. Okay, so there is a fixed number of numbers. So it is a finite set. Now x is an integer and x is less than 100. So we want integers which are less than 100. Now less than 100, the numbers will be 99, 98 and all that. Not only that, integers means even negative numbers will be a part of this set. Okay. Now at the lower side of this, when you have reached from 99, 98, 100, 0, then still you keep writing the numbers which are less than 0. -1, -2, -3, and you can see that this goes on forever and ever. That is why set B is an infinite set. Next, C. Again, natural numbers more than 100. Now, natural numbers more than 100. Again, more than 100, countless numbers are there. Therefore, infinite set. Integers, x is greater than -1. So they want integers which are more than -1. Which numbers are more than -1? 0, 1, 2, 3, 4. So all the positive integers and 0. They form elements of this set. Again, it is infinite because you can keep on listing the positive integers. Next, x, natural number, multiple of 3. Now multiples of 3, you can keep on writing and writing and writing endlessly, therefore infinite set. Next, x is a natural number and it is a factor of 1000. So if you find out factors of 1000, you will get a certain number of factors, and even if you don't find out, you know that every number has a fixed number of factors. Multiples will be countless, but factors will be a definite number. Okay, so there will be only a certain number of numbers which can divide a given number. So factors will always be limited in number. There will be a definite number of factors for any given number. So this is not an infinite set, it is a finite set. Next, G. Point on an arc of a circle. Now whenever this point thing comes, that how many points are there on the arc of a circle. Now what is an arc? An arc is just a part of the circle. When you draw angles where the vertex is, you put something like that, a small curvy thing you put, that is the arc. Okay, so how many points are there on that? Now this will be also infinite. Okay, because in between 2 points also you can always put a point, and therefore this will be infinite. Similarly, next one, x is a diameter of a circle. Diameter, what is a diameter? So whenever there is a full circle, if you draw any line from one end of the circle to the other end, passing through the center, बीच में से pass हो रहा है, that line is called a diameter. Okay, so you can draw many diameters in a circle. Like if you want to imagine the diameter of a circle, you can think of a bicycle. In the bicycle there are those rims, no? Those thin wire like things going, that is called the diameter. That is how it looks like, the diameter. So you can have innumerable diameters in a circle. So this is an infinite set. Last two are infinite. Next, state, find whether the following statement is true or false. Now here they are telling, if P and Q are two sets such that cardinal number of P is equal to cardinal number of N, then P will be equal to N. No, it will not be, because when we want to see if they are equal, we want to see which elements are there. So if elements of P are there in Q, then it will be equal. But if cardinal number is same, it is not equal. Like for example, if P is 1, 2, 3 and Q is ABC, तो दोनों का cardinal number तो 3 होगा, 1, 2, 3, so 3, ABC, so 3. So cardinal number will be the same, but they are not equal sets, so this is false. Two equivalent sets are always equal. Equivalent sets means their cardinal number is same. Okay, so will they always be equal? No. Just now I gave you an example. In this P is 1, 2, 3, Q is ABC. So in दोनों का cardinal number तो same है, but they are not equal. So this also will be false. Then two equal sets are always equivalent. So this is true, because two equal sets means they're having the same elements. Okay, so definitely the cardinal number also will be the same, and therefore it will be true. Next, you have X is a letter in the word engineer, and the cardinal number is 5. Now if you are writing this in roster form, which are the letters you would write? ENGINER, isn't it? So how many did you get? 1, 2, 3, 4, 5. No writing N, because N is already written. No writing E again. So ENGIR. So it is 5. So this is true. Next you have, let B be the consonant in the word management. Then cardinal number of B will be 4. So you see how many consonants are there. Neither prime nor composite. Which natural number is neither prime nor composite? 1. So cardinal number will be 1. It's true. And here, cardinal number of an empty set is 0. So that is also true. Then integer, and it is neither positive or negative. So which integer is neither positive or negative? It is 0. And here they are saying that it is 5, means empty set. It is not empty. It has one element 0. So this is false. Next, let A be this and B be whole numbers less than 5. You have to find out cardinal number of A and B. So first you have to write this in roster form. Then you have to tell if both are equivalent sets or not.